So in your syllabus for data structures, you have your model 3 as your data structure. So in the last video we have also seen the very brief idea about what are the things, what are array, what are double linked lists. Now in this video we will see them in depth. Now what is a data structure? As I have already told you, data structure is a way to store and organize data. So this is important. It's a way of storing and organizing the data. So it's basically organization. Now this is not a programming language. Please understand that data structure is not a programming language like C or C++. It is just a set of algorithms that we use in any programming language to structure our data. So for structuring our data, this data structure is used. So the data structure is basically the algorithms. Now there are many numbers of algorithms that were proposed, and they all are known as abstract data types. Now these abstract data types, there are a set of rules. Now what are the basic types of data? There are two types of data. One is the primitive data structure. In the primitive data structure we have the integer, we have the character, we have the float, we have double, we have pointers. So these are our primitive data structures. Now they can hold single values. Now in a non-primitive data structure, they are divided as linear data structure and non-linear data structure. In a linear data structure, the data are arranged in a sequential manner. They are as arrays, linked list, tag and queue. Now here one element is connected to the another element in the form of a linear. Hence it is linear data structure. In a non-linear data structure, one element is connected to n number of other elements, and hence the word non-linear data structure. Examples: tree and graph. We will see them, what are tree and graphs. In non-linear data structure, elements are arranged in random manner, so there is no issue with that. Now data structure can also be classified as static data structure and dynamic data structure. So what are static data structure? The data structure where the size is allocated in the compilation time only. So the size is predefined. We tell him the size prehand. In the dynamic data structure, here the size is allocated at the runtime. So while the program is running, the size of the program, the data structure is determined, and hence it is flexible. Depending upon the requirement of the program, we can increase or decrease the size of the data structure. So it is more efficient. Now, what are the common operations that are performed on the data structure? The common operations are searching. That is, if we want to search for a particular elements in the data structure, we will be using the searching algorithm. The sorting algorithms are used to sort the elements either in ascending or descending or any other way, whichever is required. Insertion, it is used to insert a new element in the data structure. Updating, if we need to update, meaning we need to replace one element with another data, so in that case we will be using the updation process. Deletion, it is used to remove the elements from the data structure. So these are the basic operations that are performed: searching, sorting, insertion, updating and deletion. Now what is traversing? Now the data structure, they contains a set of data elements. Traversing the data structure means that we are visiting each element of the data structure in order to perform some specific operations. So if we want to perform some specific operations on the data structure, we have to go through the data structure, like searching and sorting. What happens in searching? Suppose I have given you random numbers and I ask you to find out the number 4. So you will be comparing your number 4 with all the data, isn't it? So you have to go through all the data types, hence it is traversing. The similar is sorting. Just here I have given you an example. Suppose we need to find the average of 6 different subjects. So you need to know the marks, isn't it? So you will traverse for the entire marks, meaning you will go through all the marks, you will find the sum of them, then you will divide it by 6 in order to find out the average. Now insertion, it is a process of adding elements on the data structure, and it can be done on at any location depending upon our requirement. Deletion, we can also similar to insertion, we can delete elements at any location. Now if we want to delete an element from an empty cell, then it is called underflow. Means there is no element present and then you are trying to delete some element, so that is underflow. Now we can also search, as I have told you, we can search the location of the elements with the help of the searching algorithm. There are two algorithms to perform the searching. One is the linear algorithm and another is the binary search. So there is a linear search and the binary search. We will go through them in later. Sorting, as I have told you, arranging the data structure in a specific order is called sorting. There are many types of sorts. Insertion, selection, bubble sort are some of the most common and widely used sorting algorithms. Merging is that suppose you have one list of data, one list is 1 to 3 and another list is ABC, and I want to merge them together. So I will be having a list called 1 to 3 ABC. So that is merging of two data. It's clubbing or joining. Now this is the basic structure, data structure. It is divided into primitive data structure, non-primitive data structure. Non-primitive data structure is divided into linear and non-linear. The linear is static, dynamic, and non-linear is tree and graph. This dynamic can be distributed as linked list, tag, and queue, static to array, isn't it? So we will go through all of them, starting with array. We will go through array, then stack, then queue, then linked list, then tree and graph, and we will see all of them. So this is your entire syllabus. This entire syllabus comprises of this only. Now, what is an algorithm? An algorithm is a process or basically a set of rules which is required to perform the operation. So you will give a set of rules to the computer to perform so that you get the desired output out of it. The formal definition of an algorithm is that it will have a finite set of instructions which will be carried out, which will be performed in a specific order to perform a specific task. Now, whenever we are speaking about algorithm, we also need to verify the performance of the algorithm. So there are two parameters by which we will verify the algorithms. One is the time complexity and another is the space complexity. So what is the time complexity? Time complexity is the amount of time required to complete a operation is called time complexity. Meaning how much time do you require to perform a algorithm to get the desired result. That is time complexity. How much time? And it is denoted by the notion O. Now, as I told you, what is algorithm? Algorithm is a set of rules. So time complexity is basically counting the number of steps required to finish an algorithm. Similarly, space complexity, it is the amount of space required to solve a problem. That is, how much amount of space do you require? Now, what are the things that takes out space? Obviously, space is required to store the program, to store the values, to store the variables, to track the function, jumping, everything. All of this requires space. So space complexity is how much space is required, and time complexity is how much time is required. You already know what is a pointer. The pointers is a special type of structure where data structure where it is used to point the address of the value stored. So in the memory, the data are stored. So you need to know the address. If you want to find out the address, you will be using the pointer in order to find out. Okay. To obtain the value stored in the location, we will be using the term called dereferring. Now, I have a very simple example over here. As you can see, this is a simple example where I have shown you the execution of the pointer. I will provide you with the file, or else you can directly copy it from here and you can use it in any of the. Let me just copy it. I will provide you with this code. It's a very simple code, you can write it yourself also, or else you can copy it and then you can execute it on. I'm using code block. You can use any editor. You can also use online editors. Save file as, obviously it is a C file. I will save it as the name of C. Now I will suggest you kindly turn off your antivirus, or else if you use it in code, you might face some problem in execution. So it's preferable. So this is a simple program. Let me run it and see what happens output. So this is the output. You have already done C programming, so you have a basic idea. As you can see, A is an integer which is having the value 5. Star B is the pointer which is referring to me. So percentage D is A, so I am getting the value What is pointer of end of a? What is end of a? End of a is basically the address, and pointer of that is the value present at that, what is, which is the dereferring. So this is basically the dereferring. What is pointer of b? B is basically the address of a, so pointer of b is dereferring of a, that is the value which I am calculating. What is end of a? End of a is the address, the location at which this a is used by this stored, and that is what I'm getting. Now in order to use the word, see the address, we need to use percentage u, to keep that in mind. Percentage u will give you the address. It's a simple program, just do it yourself. I'll provide you with the code also. It's not something very fancy thing, you can do it yourself. We also have another code over here similar to the last one. You can copy this also, or you write it yourself. I will suggest you write it yourself and then you do it. So let me save it by another name, tree.c. So run it. Okay, see why it is not running, why I'm not getting the symbol to run, because the last program is still in execution. So close it and then run it. So kindly go through this code and see the result and see how things works out. Okay. So we'll continue structure in the next class. Thank you.